at the end of the session prior to our break, what we get to see is, just to recap within a few seconds, without logging, there's absolutely no way for us to track our code. There's no way to track any errors over the last 1 week, 1 month, or whatever it could be. So to perform all of these operations, it's quite important to track these, and that's where logging comes into picture. Now, there's a reason why I do not prefer the default logging mechanism that's available within Python. That's purely because the default logging mechanism is quite complicated when we start to think about it. It's quite complicated when we start to work on it from basics. Before I continue ahead with this, I'm so sorry. Give me a few seconds. Kindly hold on. Apologies for the slight delay, guys. Going back into this, let me just properly set up my mic. I'm having some slight issues on this. Right, there we go. This should be fine. So back to the point. Um, Logging is quite important for us to work around for these reasons. Now, the default logging library, that is logger, that's available within Python, is quite complicated to begin from scratch. When I say quite complicated, it has too many boilerplate code. As a developer, you're not supposed to work on boilerplate code much. That's the whole idea. And for those who are not um, aware of what boilerplate code is, it's pretty much a part of the code that is repetitive, or it's a template that you have to do over and over again for every new project, which is better if you don't do this, because it's just an unnecessary step of a basic structure of a program which can be automated. So for this purpose, to avoid inbuilt logger, we're going to use a wrapper over it called loguru that we're going to use. So let me just walk through this. This is the GitHub repo for loguru for those who are interested in checking it out. The whole idea of this is it avoids all your basic boilerplate code that's available within Logger. You can just add Logger with a very small piece of code without too much complication and run it. Now, before we add this into our code, there's one important thing that we need to know. That is, whenever we start logging, and a very important thing for us to know is there could be multiple files throughout your process. You can have one file called, let's just take a random assumption here. You can have one file, let's say called application.py. You can have another file, let's say called service.py. You can have another file, let's just assume and call it um, let's say if you're accessing something like ChatGPT, to do that, let's say you might have something like gpt.py, you might have another repo.py to access a database. There could be multiple files, and you can have another thing called utils.py as well. Now, there's a reason why I'm putting out all these. A common structure, a common way of any real life applications that we develop within Python includes something like this. And since we're going to develop our first application, I just wanted to point this out and I just wanted to walk us through this to begin with. Now, let's start with this. Your application, backend application, will have at least 4 layers, or at least 3 layers to begin with. Let's start with that. The first is called an application layer. The other is called a business layer, or sometimes also referred to as service layer. There's an ambiguity between them. Sometimes people separate business and service layer. Sometimes people combine both of them. So let's not worry too much about it. Let's just call it as business or service layer. And there's another thing called database layer. The idea is that you're going to have a Python file which user will interact. The moment user will interact this with this file through, let's say, JSON data, for instance, user will send some JSON data to this file will read that JSON data, and the moment it reads JSON data, this file itself will not go to the database, get the data, perform some computation, and provide the response. It doesn't do that. Instead, what this particular app layer file does is it instead sends this information to the business layer or service layer Python file, which will perform all the computations and operations that are required. It does not directly access the database as well. To access the database, you're going to have another separate layer called DB or database layer. And this particular layer is the one that's going to access the database. This is another Python file that's going to access the database. Most of the times, applications are developed like this. And I'll just give you an idea why. This database layer is going to have basic functions to access database, like connect to a database, insert something within a database, delete something from a database, search something within a database, update something within a database, and so on. So there could be 5 different business layer files, one to perform some text operation, another to perform some image-based operation, another to perform some video-based operation. If all of them need to access database and you have to rewrite the same code in each one of them, to access database in the image file, you have to again write the connection code, the insertion code, the deletion code, updation code, everything. And even here, all the CRUD operation codes, you need to write everything, even in the video service code and everything. To avoid that, we create a separate file, generally titled as repo.py. This particular Python file, only purpose of it is to connect to database, perform these following operations, and that's pretty much it. There's no other function apart from that. So any service layer, it could be the image application, text application, video application, any service layer which performs operation on top of some computation, some calculation, any such file that needs to access database will reach out to this file, will reach out to this Python file. It'll reach out to this Python file and ask, hey, I need to insert something in the database. Or this is going to reach out to this file and say, I'm going to delete something from the database. So all of them have a common code so that you don't have to rewrite it in every service level. That's why we divide them. That's why we separate them. So when you look at code, this is how we often write code in real world applications. This is why you have files like this. So I'm just going to give you one simple example so that we understand why we divide it like this. And then we're going to apply that to an example that we'll work on. Let's think about this. Let's say you have a Python code in the backend to perform the following operation. The moment you provide an image of, let's say, your health record, the purpose of this Python file is to take that health record and then store it within the database so that it has access to it. The purpose of this Python file is also to decode this health record image. It could be a scanned image, right? So it might need to perform OCR. OCR stands for optical character recognition, where it has to look at characters within that image, read them, understand what is written within them. And after understanding what is written within them, it needs to separate them into different factors, like name could be somewhere, age could be somewhere, or let's say blood sugar levels could be somewhere, and so on. Each parameter could be somewhere different. It needs to extract them and then store them in the database as well. So there are multiple things we need to do here. So we need to take the image, store it in the database, perform OCR on top of it, store that content in the database as well. So for such an application, let's see how this layering will be happening. First, let's start with our database layer. We're going to have a repo.py at the end. This repo.py file is going to be your database access layer that's going to connect to the database. The only code you will write within this file is code the functions to connect to database, to insert in database, to delete in database, and everything. These are Python functions that can connect to the database, perform all the operations, and provide response. That is what we write within this. After repo.py, then let's divide this into two separate categories, which I'll explain further in detail. One will be business, the other will be service or utilities, and the application layer. Application layer will have something like app.py, which are most of the times we call it as controller.py. The main purpose of this is to ensure that it creates routes where people can submit images. When people submit images to controller.py, the purpose of controller.py is to figure out if it's an image, what to do with it. Or if a person is just asking for their latest health records, the purpose of controller.py is to just pass it to another file which can provide that information. So controller.py just serves as intermediary. It does not access the database. It does none of it. It just performs this. Now, here's what it does. If you're supposed to store the content into database, we call some file called store.py. If you want to perform the store operation, you call store. If you want to retrieve something, you will call another py file called retrieve.py. Now, the idea of these files are they will use some additional files called utility files. To store, you need to perform OCR. To perform OCR, you need a lot of image-based capabilities like read an image, convert to grayscale, black and white, or identify text within it, perform OCR, all these things. So for that, we'll have some utility files like imageutils.py. The purpose of this is to make sure that it has all the content that can be used for image-based operation. So if there's a new file that comes up and this requires some image-based operation to do, it can directly access this imageutils file. The reason for that is to make sure that if you store all this content in store file and there's one more code that comes in to do something with an image, then you have to copy all this code and paste it here as well, which leads to repetition. To avoid that, all common code that you might assume could be common code that might be used in the future will be stored in a separate file, let's say imageutils.py and so on. This is how a real world application is often divided to an application layer, business layer, utilities or service layer, and the database layer. So I hope the basic idea of this makes sense. I hope the basic idea and logic of this makes sense. So if there are any questions in here till now, please let me know. I'll just wait for a few seconds if there are any queries. All right. Perfect. So no queries still here. I hope this makes sense in that case. I really hope this makes sense because there are a lot of things that we will keep performing within this. There's a lot of things that we will keep doing within this, which is going to be quite useful over time. This idea, this logic is going to help us. And here's why I provided this logic. The reason why I provided this logic is we're going to perform logging with such a dummy application. We're going to perform logging on an application like this. So the application we're going to have is as follows. We're going to have an application layer where we will send information in text. Once we send information in text, this application layer should then connect over to a service layer file, which should perform text to speech operation. That is, whatever text you send, it should convert it to a speech audio file, and it should then create an audio file. Once that audio file is created, it should then be able to provide back the information. Now, there are two files here. I might have one more service file. I might have a database file. I might have a utilities file. There could be so many files. Now, the problem here is logging. Each one of these files should log information to a single file. To do that, to make sure that all of them are logging to a single file with the same format of logging, you need to use a common logging object across each one of these files. And that's why we use logger as a separate um, object in some other file. Could be something like commons.py or global.py or something. Some of us even use config.py, where we create a logger object, and that logger object is then imported by each of these files. And each of these files uses that exact logger object so that all logs are stored in a single file. This is what we get to do. I hope this makes sense. I hope this helps out just to understand what we are doing in terms of logging and how we are working on top of it to begin with. With this, let's start our logging application. So I'm going to create a new directory on Python in the basic that is in our root directory. I'm so sorry for that. Let's create a new directory. Let's call it logging. Right now, to perform logging within this, we have to start working on and learning how to create our own application or a simple application that can perform these or some sort of operations at least. So let's start doing that. Again, prior to this, I'll just mark a couple of things. These are done. This is not done. So a couple of modules we need to learn because we are going for logging based application. I'm going to look into these modules later on. So I'm just going to point them out here so that I don't forget them. We have date time, relative delta, and regular expressions. So we're going to look into these later on. Right, let's go ahead and start logging. Now, let's create an application dot a file dot app dot py. Now, one question before we go ahead. Most of the real world applications that we might create, most of the real world applications that we might build will be built on some sort of framework, right? So most of the time we build it on some sort of framework like Fast API or Flask or Django. This is not a part of the syllabus that is or the content that is provided to me. However, I highly suggest that if you're going to create any real world applications, any real life applications ahead, it's important to know at least one of these, so that you can perform some basic operations, basic enough that you should be able to create an application where if you send a request, it'll perform some operation and send a response. The whole idea is, let me repeat this, there's not much point in learning Python where you have to run all the code by yourself. The idea is that you can send a request to this Python application. It will interconnect between different files, perform some operations, and provide the response back to you. So that's why there's these three frameworks. And I'm going to use one of these frameworks in our current application. Just so you know, these frameworks are not complicated. They're not difficult. They just have different purposes for each of them. Django has a steep learning curve, a very steep learning curve, but it's very useful if you want to create all in one application. If you want to create a single Python application, which will take care of your login, your authentication, your database connection, and let's say your auth token provision, whatever it is, if you want to create a complete application that takes care of step A to step C, everything together, Django is the one thing. That's why it has a steep learning curve. And it has so many components to it, it makes it quite difficult to learn from scratch at a quick pace. So a lot of people use it only if they want to create an all-in-one application where everything can be done within one single application that is connecting to database, not just these, like logging in, authentication, um, auth token based authentications, load balancing, whatever it is. Everything that you want to do, if you want to do it in one application, you go for Django. So we're not going to do that. That's not our purpose. We can either go for Fast API or Flask. Fast API is a relatively newer framework that has come up. It has a lot of nuances to learn within it. So it has a moderate learning curve, not too steep, but the easiest learning curve is a Flask that is a framework. And this is the framework we're going to use to create our very simple application in a very quick way. So that's what we're going to do. So let's get started with one application. And our application, or the application we're going to do, is a pretty simple one. We're going to have an application that can take text as input and then create an audio file out of that text. So if we provide text as input, it's going to create an audio file as the output, which we can play at the end. That is the whole purpose. So for this, I will reshare my screen to avoid this issue later on. I'm going to reshare my screen so that I can share my computer audio as well, so you can listen to what's happening in the background. So let's go ahead, and I'm going to share the system audio as well. There we go. This should be fine. Um, I'm just going to play some random audio just so that you get to listen to it and you're able to listen to, let's say, audio samples at my end.
This is Peter.
This is Johnny,
Kenny. And Josh.
We just wanted to take a minute to thank you.
This is
All right, so I hope you're able to hear the audio. Yes, perfect. Thank you so much. So this means it's working well, so we can do this. Awesome. All right, now let's get started with our application. But before we start with our application, the first thing we need to learn is logging. So let's start with logging. Our main purpose is logging, but this is going to have a lot of things. So I'll call it as GTS application, our own text to speech application. Let's start with this. I'm going to create a new file. Let's just call it as dummy.py. And the main purpose of using this dummy.py is so that we get to know how to perform logging, how to um, do simple logging operation. That's the main purpose, nothing else. Right, so let's start with this. Right, so prior to that, again, if you have any query in between, please feel free to ask. If none, that's fantastic. So please feel free to interrupt anytime you have any queries. I'm happy to take up any queries that you might have. But let's get back to this. Now, I can import logging by default and work on it. But the problem with logging most of the time is you need to have logging dictionary within Python. A logging dictionary, a log dictionary often helps. It's basically called a dictionary configuration. This helps you create better understandable logs. And there are a lot of things that you need to look into it. There are a lot of things that you need to work around it. So to avoid all of these, I will be using Loggeroo. So let's start with this. First, loguru is not an inbuilt um, logging, let's say, library that's available in Python. Instead, Loguru is a library that's made by other developers, which is a wrapper on top of Logger. It's just another layer on top of Logger to make it easier. That's the whole purpose. Just like Python is another layer on top of older programming languages to make it easier, similar to that. Let's start with Logger. So the first thing is to install it. Let's go for pip install Logger. This should install Logger over in your Python package list. Pretty simple. Pip install Loguru. That's it. Once you have installed this, you can then start using it. That is from Logger import logger. That's it. This logger is what we're going to use throughout our application to log anything. That's it. From logger, import logger. That's all. Now, don't just directly log things. We need to find a way to store, find a place to store loggers. Oh, yeah. And one other thing, in reality, one thing that is very important to note in logging is be aware of your log size. Over time, your log will increase in size. It may be just 100 KB today, but it might just be 50 MB in a few days. It might just be 1 GB in a few days. And over time, when you have logging of your Python application in a cloud-based server, your entire disk space may be full because of this logger. And because of that, your application may not be able to run at all. I have seen this a lot of times this has happened. People are unable to figure out why nothing is working because there are no errors, but little do they realize the logger is full, which is why the disk space is just full. One of the best way to handle them is rotating log files. That is, you can either choose to create a new log file each day or each month and delete the older one, or keep a limit for log files in terms of size. Log file should only be 500 MB in size. After 500 MB, each line you're adding, you're deleting the oldest line or something like that. So there are such rotating logging mechanisms that you can use, which are available directly within Loguru. These are a lot of advantages that you can have. And just looking at this GitHub repo will help you understand everything about it. So let's start with this. The first thing you need to do is figure out where do you want to log? Which file do you want to log? That's the first thing we need to figure out. Again, I'm skipping a few of these things because we'll do this ahead in time. We don't have to worry too much about it right now. But I'm going to start with this, the basic thing. We need to log in a file. So let's add a particular file. I'll just make it as logger.add of info.log. That's it. I'm just creating a simple file name called info.log. All logs created will be stored within this. And I'm not creating any specific format of it. Whatever is the default format, I'm using it. There are other ways to format it, like you want time first, then which level, that is debug or error or whatever it is, then message. There are multiple ways to format it, but I'm not going to look to format it. We just want to log our messages. We'll look at formatting some other time when we are able to. Let's not worry about it now. Now, once you add a file, as I talked about it earlier, you can add rotation, like automatically rotate if it's a very big file or new file created each day or each week or some days. After some days, delete the previous file or compress them to save space. There are so many additional things you can do, but we're not going to do any of this. That's all we're going to do. That's pretty much it. Now, another advantage of Logger is within Logger, any string you write, um, you can directly utilize curly braces and use a feature to add whatever you want to add in those curly braces. But I still prefer formatted strings, so I'm not going to use this. That is my preferred way of approach. All right. So there is a logger.catch, but I'm not going to use this. I will use the traditional way to do this. So yeah, let's just go ahead and continue ahead. Now, moving ahead, one other best practice that I just want to point out. I know I'm pointing out a lot of best practices before even starting the code, but I'll be honest, just this code you can learn from anywhere, literally anywhere. Probably ChatGPT is going to explain this code and how to work around it better than I can ever, right? Because we have so much info available across the internet. But the experience that comes from it to make sure your applications are really well done, that's quite different. So that's why I keep adding these. So I hope that helps out regardless. So yeah, the point I wanted to add within Logger was, let me get back to this. Yeah, the point I wanted to add within Logger was, think about this. There are 5 different files which are storing logs in a log file. Now, each time it stores the log in a log file, what ends up happening is there's a line of code here called logger.debug or warning or error or whatever it is. It has to open this file, save that line, or write that line, save this file, and then go back. It has to keep doing this constantly.